Hello, welcome to my channel Devops with Prasanna. This is day 18 in Learn AWS in 30-day series. And today we are going to talk about an infrastructure as a code tool called Terraform. So we are going to do the same exercise as before. We are going to create a EC2 instance along with the dependent resources. So this is the source code which we are going to look at. And we are going to cover pretty much the basic concepts of the Terraform constructs. And it's going to be a very interesting hands-on session. Yeah, I'm very much excited. Let's get started. Intro to Terraform. So we'll quickly see what is the difference between Terraform and AWS CLI. By that way, we'll understand Terraform in a lot better way. This applies to any IAC tool in general. There are many such infrastructure as a code tool. Terraform is one popular tool. Like I've used Terraform in pretty much all the client projects. So it is that popular. But the other tools are Pulumi, CloudFormation, which is AWS infrastructure as a code tool. We'll see about those in the later sessions. Okay. Yeah, infrastructure as a code tool, Terraform. So the core difference is it follows a declarative style, whereas CLI follows the imperative style. So what is meant by declarative style? So for example, when we want to create certain resources, in this example, we are creating the EC2 instance. Okay. So if we want to create EC2 instance in Terraform, we'll say what is the end state should be, or what is the state of infrastructure should be. So for example, we'll say we need EC2 instance with this security group attached. It should belong to this subnet. This is the information we'll say. We'll define what is needed. Okay. And Terraform will take care of going to that state. So for example, if it doesn't contain any EC2 instance, it will create the EC2 instance. Okay, it will create it. If it already has a EC2 instance, but it has a different subnet security group, it will update the EC2 instance, so it will have the proper security group. If it if we don't want the EC2 instance, like if we remove that from the code, and if we have a EC2 instance in our infrastructure, it will go and delete that infrastructure. So Terraform knows how to perform that operation, okay, so that the desired state can be achieved. That is what called as declarative style of programming. The imperative style, on the other hand, means you will say how to do it. For example, when we are creating the EC2 instance using AWS CLI, we said like, okay, use AWS EC2 and then create instance command. Okay. So you'll exactly specify what you want to do and how to do that also. So there is like no intermediate person who will compare the state and take necessary actions. So that is the thing with imperative style. Maybe like I'll slightly go further so you'll understand it in a lot better way. Okay. So if I try to run this AWS CLI commands for 3 times, okay, then what will happen in the imperative style is it will create 3 different EC2 instance, because we are saying like AWS EC2 create instance for 3 times. Okay. So it will create 3 EC2 instance. But in case of Terraform, if we try to run it for 3 times, it will not do anything, because the first time it will create the EC2 instance, but for the subsequent times, it knows the state is already matching. So it will not do anything. So this is the power of declarative style versus imperative style. And this declarative styles, requests are idempotent, which means even if you run the request multiple times, it's not going to affect your infrastructure. But in case of CLI, requests are non-idempotent requests. If you run it multiple times, each and every run will change your infrastructure state. Okay. And there is like some programming concepts involved here in using the Terraform. And the language which we'll use is called HCL. HCL stands for HashiCorp language. So this Terraform is a tool created by a company called HashiCorp. So it's a very good company. There are a lot of other tools created by HashiCorp, and they are pretty good in their usage. So in this Terraform, we are going to use a language called HCL. And as we discussed, Terraform maintains a state. So for example, when we ask Terraform to create a EC2 instance, it will create the EC2 instance and it will create something called a state. And whenever we try to run the Terraform command again with the code change or without any code change, it will try to compare the code with this state, and it will see like what is the difference, and it will try to make those difference in the infrastructure. So that's what it's going to do. So Terraform maintains a state, and this is very helpful in maintaining the infrastructure. So to compare this against the CLI, there is no state maintenance, and it is very hard to maintain the infrastructure. The reason for that is, let's say you are updating a rule in security group. Okay, so you're going to update one rule in security group, but you're not going to change EC2 instance or subnet. In case of CLI, you have to comment out all these things and only have the security group, and then run this security group so the rule will be added. Okay, that is a maintenance nightmare. In case of Terraform, like you don't have to comment out any of these things. You just add one more rule to your security group, and Terraform will compare your code against the state, Terraform state, and it will know like only this rule got changed. So it will try to create that create only that rule. So this is the power of Terraform, and this is where the infrastructure maintenance is becoming very easier. In pretty much all the big companies, they'll use Terraform as an infrastructure as code tool. Only for the debugging purpose or to have one-off activities, we'll be going for AWS CLI. Okay, cool. And this is a cloud agnostic tool. So which means we can use Terraform against AWS. We can use Terraform against GCP, Azure. It will even have support for Kubernetes and various other resources, various other providers or various other technologies. The reason for that is in Terraform, there's a concept called as providers. So providers is nothing but a sort of plugin. So there is a Terraform core, and there are a lot of providers available. So AWS will have a provider, GCP will have a provider, Azure will have a provider. And this will have a specific set of resources to manage the infrastructure in that cloud. So it has more than 1,000 plus resources. Resources example is EC2 is a resource. So in AWS Cloud Provider, there is a resource called EC2, which can manage the EC2 instances. So that's how it's going to be. And there are like more than 1,000 plus resources available across the providers. Cool. So, but there is no concept like providers in case of CLI. So, and for each and every cloud provider, you have to use a specific CLI corresponding to that provider. So AWS, we use the AWS CLI. Okay. So this is cool. So I thought that this will give you a very brief understanding of what Terraform is. And in the subsequent sessions, you will understand Terraform in a lot better way. So we'll quickly take a look at how Terraform works, and then we'll jump into the demo. We'll see all these things in a practical example. So the first thing is Terraform configs. So this is going to be your HCL, HashiCorp language code, which you'll be creating. So if you want to create a EC2 instance, we'll have a code to create EC2 instance here. Okay, so this is a TF configs, and this config will be passed to something called as Terraform core. Okay, this is a core engine of Terraform where it will try to compare the code against the state. This is called TF state. Okay, Terraform state. If this is the first time you are going to run your code, then there will be like no state, which means it will create all the resources available in your code. But in case of the second run, it will try to compare the state with your code, and it will create something called as plan. This is called Terraform plan. This plan will define what are the changes it's going to make in the infrastructure, what are the resources it's going to create, what are the resources it's going to modify, and what are the resources it's going to delete. So all these things will be shown in the Terraform plan. So once this is done, then Terraform core will use the corresponding provider which we are defined in the settings, and then it will make changes to the corresponding cloud environment. Okay, so this is called as apply phase. So we have seen two phases now. One is a plan phase, the next one is a apply phase. Okay, and similarly, like if we can use multiple providers in one Terraform repository, and it can make changes in the corresponding providers. Cool. This is the basics of how Terraform works. We'll see this in action now. Demo to create EC2 instance. So while creating the EC2 instance, these are the steps which you are going to follow. Like we are going to get the VPC information, get the subnet information, create a security group along with SSH access, get the AMI ID, and then create the EC2 instance and then delete the EC2 instance. So these are the steps which we are going to follow using the Terraform code. Cool. So the first section, I commented out most of the code here, and I'm having only the initialization part and the VPC fetching part. Okay. So this is a Terraform block. This is called Terraform settings. So you're going to say, I want a provider called AWS. It is coming from HashiCorp AWS, and this is a version. And you will say in the provider settings, you will say like what is the default region it should use. And you can give access key and secret key here, but I'll not prefer using it that way. Instead, I'll set it in the command line and use that from the command line instead of having it in the code, because there is a very high chance like you will commit this code unknowingly and your secrets will be exposed to the outside world. So this is the provider settings. Okay, this is Terraform settings and provider settings, and this is going to be the first resource which you're going to see. So to create EC2 instance, we need a subnet ID, and subnet needs VPC ID. Okay, so I'm going to get the VPC information. I'm saying something like data. This is a resource name, AWS VPC, and this is the name which I'm going to give, my default VPC. And I'm just saying like default VPC. So whatever is a default VPC in my AWS account, please fetch that one. And I have one more block which is called as output. I'm saying the default VPC ID is data.AWS VPC, my default VPC.id. So this is the output which I want to see in my screen. Okay. So this is a very simple AWS Terraform constructs which we are going to use. So to use this one, I'll say Terraform. Yeah, just okay. I'll say Terraform Plan. And before this, I should always point to my right AWS bucket. So AWS. This is my AWS profile, and if I say AWS S3 you can see I'm pointing to my correct AWS bucket, AWS Cloud. Okay. Now I'm going to say Terraform Plan. Okay. So if I do this, you can see it's reading my code, and then it is giving me this output. The default VPC ID is whatever the VPC ID which I have. Cool. So this is not going to make any changes to the infrastructure. It's just going to output a variable for us. Okay. This is a very simple step which we have performed. But we could able to run the Terraform against our cloud and see the result for us. So basically, I think you would have got the idea. So it is talking to our AWS account and fetching the default VPC ID and showing this as an output. Okay. Now what we'll do is we'll use this VPC ID and then fetch the list of subnets in it. Okay. So this is AWS subnet IDs is a resource name, and we are going to name it as available subnets. Okay. Maybe I'll say my available subnets. Okay. And for this, the filtering criteria is VPC ID. So I'm giving this VPC ID. I'm passing it from data.AWS VPC, my default VPC.id. Okay. And I'm outputting two variables now. One is the list of all available subnets. And the second one is only the subnet I was interested in. So I can create the EC2 instance in this subnet. Okay. So the syntax is slightly weird. Like I'm sorting this by keys. The sorting by the values, and then getting the second subnet from here. So if I run this one, has not been declared. Okay, because we changed the name to my available subnets. I'll say my available subnets and my available subnets. Okay. Cool. So we have a lot of information here. We'll check this one now. Okay, so it's reading the information, the code, and then it's saying these are the available subnets. There are 3 subnets available, and the default VPC is this, and my subnet for my instance is going to be this. This is the second one, if you see, 0, 1, 2. Okay, cool. So this is going to give us a proper output for subnet and VPC ID. The next one is we are going to create a security group. So again, we are going to say AWS security group SD from TF. And this is the first time we are going to create a resource in AWS. If you see, the type of the Terraform concept is resource. For the previous 2 things, we give the type as data because we are going to fetch the data from our cloud. Cool. We are going to create this security group in this VPC ID, and there is one Ingress block here, which will say allow the port 22 from anywhere. So this is a CADR block which we'll give. Cool. Okay. So I'll go here and I'll say Terraform Plan. Okay, cool. So this output looks interesting now. So it's going to create a resource for us. So the resource name is this SD from TF. And you can see there is a plus sign here, which means it's going to modify our infrastructure. It's going to add this particular resource. And in the plan output, you can see there is 1 item to add, 0 to change, 0 to destroy. Okay. And these are going to be our output. So that is a best practice to be followed. Maybe we'll do that itself. I'll say out as plan.out. What this means is capture the plan and store it in a variable called plan.out. Cool. We can see the same thing again. So there is like 1 item to be added, and this item is security group. So now I'll say Terraform apply. I'll say plan.out, which means use this plan and make the changes in infrastructure. So this is going to actually create a security group. So if I go to my infrastructure, if I go to security group, I can search for SD from TF. Okay, there is no resource here. I'll run this one. It will usually take a few seconds, and then it said like apply complete. We have added 1 resource, and this is the output variable, which is like the default VPC area and things like that. If I go to my AWS account, and if I refresh this again, I think I renamed it wrongly or something. Oh, I didn't give any name here. This is a Terraform name. Okay. Ideally, I should have given a name, but I think like it's fine. So I can give a security group name. This is a good option for us to showcase how the resource modification will be. Okay. So for that, what I'll do is I'll go to the Terraform documentation and then get the exact attribute which I have to pass. Okay, so for that, you have to go to terraform.io. And I should say, if you compare the Terraform documentation with the AWS CLI, Terraform documentation is a lot better than AWS CLI documentation. So you can go to docs section. You can find a lot of tutorials and things like that. I'll go to the documentation. Okay. And we want to look at something called as the Terraform registry, where we'll see about the various providers. So if I go to Terraform registry, this is a home page. We'll browse to the providers. We'll go to AWS. Okay, so this is a home page. We'll go to documentation. And we want to look at the resource called security group. Okay, this will be available in resource section called security group. It is under the VPC. Okay, and what we want to do is we want to give a name here. Okay, and name and description maybe. So I'll come here. I'll say name as SD from TF. Okay, I'll give a description also. Allows This is inbound traffic and all outbound traffic. And I'll add a tag also here. The name should be ESG from TF. Okay. So if you remember, we already ran the Terraform apply command, which means our security group is already created. But now I'm going to run this command again, plan output. Now it will compare the, cannot begin with yes. Okay. Okay, I'll change the name to security group. So it will compare the code against the Terraform state, which is already available. And then it will try to find the difference, and then it will try to do the difference. If it can do the modification, it will do the modification. If it's not possible to modify, it will delete this resource and recreate the resource. Okay, we'll see what Terraform will do now. Cool. So you can see this must be replaced because it can't do the modification. It's going to replace the entire resource. Okay. So it is the description is going to change from managed from Terraform to whatever the description we gave. The name is going to get changed from this to security group from TF. Okay. And you can see it's going to destroy one resource and then add one resource. Cool. Now I'll do Terraform apply plan out. So the destruction is complete and creation is also complete. So the summary is one added, one destroyed. If I go here, if I search for security group from TF, you can see we have our group and then it has one inbound rule, which is like allow 22 port from 00CADR. This is cool. Now what we'll do is we'll fetch one more information, which is the AMI ID, which we have to use. So there is a slight construct the new option which we are going to use here, which is called filter. So if you remember, like there are a lot of AMI IDs available, okay, but we want to filter based on certain criteria. That's what we did in this AWS CLI session. So similarly, we are going to filter by name, and this should be the name of the Ubuntu image which we are going to use. And there are multiple filter conditions. We want to have a root device type as EBS, and the architecture is x86 64. Okay, we want to fetch this, and maybe like we want to output this also. So what I'll do is I'll define an output block. I'll say value equal to, I'll say data dot my AWS AMI dot Ubuntu dot. I'll say I want to get the ID of ID, which means it will give me the AWS ID, and the output, it should be, we should give a name for this output. My AMI ID. Okay. So this is what I'm going to output. Maybe I'll use underscore. Cool. If I run this one now, if you remember, like it also has the code for creating the security group. Okay. But it will not make any change because the security group is already there and it is matching with the resource. Okay. So if you see here, it will read the code and it will compare against the state. It will say this is the only change. There is a change to our output variables. And this is going to be the output. Okay, cool. So even if you do apply, it's not going to be a destructive one. This is the power of declarative language. Like I can run the Terraform apply command multiple times, but it's not going to make any change. So if I do Terraform plan, apply plan out, it's going to say 0 added, 0 change, 0 destroyed. And it'll give the output where we'll get the AMI ID also. Okay, cool. Now we'll go to the actual part of creating a EC2 instance. But before creating an EC2 instance, I thought I can introduce one more thing, which is called variable. This Terraform construct can allow the variables and values to be passed from the outside world. So meaning I can, when I'm going to create a Terraform plan, I can pass a value to this variable and this will be used to create this resource. Okay. So in this case, I'm not going to pass any variable name. Because I have given a default value, it will assume this value for this variable and it's going to use that one. Okay, cool. So this is a resource which you're going to create and this is the output section. Okay, in this case, we are going to use a AMA ID, which is already fetched for us. We are going to use a subnet ID. This is going to be my available subnet IDs. And then we are going to get the last subnet ID. The instance type is going to be T2 micro, key name is going to be Prasanna. Security group is something which we already have. If you remember, like this is a name which we give in the Terraform resource name. We search for this, you can see this is a name. We just changed the name in cloud, but this name belongs to Terraform's resource name. Okay, so you should not confuse this with the cloud name. Cool. And then associate public IP address, and we'll be having a tag also. If you see this tag, it is coming from var instance name. This instance name is the variable available here. Okay, and it's going to assume the default value. Cool, and it's going to output the AWS instance. My first instance is a variable name, and then public IP address. So we're going to get the public IP address of this one. Cool. Now I'll say Terraform plan -out as plan.out. Cool. So it will say it's going to create one resource with all these attributes. Okay. And it's going to output the instance public IP, and we'll know only after applying this change. Okay. So I'll say Terraform apply plan.out. And also I'll go to my console, and we can see there are, if I refresh this one, there is one instance which is already in the pending state, which means that Terraform, it started creating the resource for us. Okay, once it is up, we'll know the public IP address, and the instance will also be in the running state. Cool. Okay, so apply is complete, resource one added, and if I go here and if I refresh, you can see this is in the running state now. This is great. Maybe I'll just show one more thing, which is to pass the variable value from the outside world. Okay, let's say instead of having a default value for the variable, I'm going to say Terraform plan, and then I'll say -var, instance name is going to be my instance, and I'm going to create a plan output for this. If I do this, it will again compare the state with the code, and it will say something like it must be replaced. So if I want to change the name of my instance, it's going to delete that instance and recreate this instance. But the catch here is, from instance, from TF default value, it's going to change the name to my instance. This is what it's going to do. This Terraform plan is a very good thing because you know what the Terraform is going to do against your environment. So you should always check your plan, make sure it's going to do the relevant change, and then do the apply. Okay. So in our case, it's going to add one resource, destroy one resource. So I'm going to say Terraform apply plan.out. Cool. So it will destroy my instance and then recreate the instance. If I go here, you can see it is in the shutting down phase. And Terraform will create the instance again with a different IP address, but with the name my instance. Okay, cool. So while it's creating, we'll take a quick look at the constructs which we saw. So provider. So provider is the AWS provider which we used, and there are some settings to be used for this provider. So we defined the default region is AP South 1. That is one of the settings which we gave, and we didn't give the other settings like access key and secret key because we set that in the command line terminal. The next one is a resource. So this is something which Terraform is going to manage. Okay, Terraform will manage for us. We created a resource called security group. We created a resource called EC2 Instance. There is something called as data. Data is slightly different from resource, where data, we are going to get information from AWS. but we are not going to manage it, meaning we are not going to create that resource, or we are not going to make any changes to that resource. This is equivalent to get operation. We are just going to get the information and use it in our resources or in the Terraform code. The next one which we saw is variable. The advantage is we can pass the variable value from the outside world into the code. And we saw something called as output. So output is used to get information from the Terraform state or from the cloud and print it to the console. Okay. So these are the Terraform constructs which we saw. Now we'll quickly check the state. Yeah, you can see the destruction is complete, and creation is also complete after 32 seconds. Cool. If I go to our console, if I do a refresh, you can see this instance got terminated and my instance got created. And it will have the public IP address 13.234.33.37. This is the output which we would have got. Cool. So I think this demo would have explained the different constructs which we use and how to have a basic understanding of Terraform. So if you want to have a in-depth understanding of Terraform and what are the best practices available, please let me know in the comments. I'll do a deep dive session in Terraform and how I'm using it for various clients. Before wrapping up the session, I thought we should quickly talk about the 4 important commands which we have. The first one is init. Actually, I ran the init command before our session, so you couldn't see that init command, but we'll quickly talk about this init command and what it will do in our local. So, okay. So if I, for example, you can see there is a folder called .terraform. Okay. If I do ls in this Terraform folder, you can see there are various, there's a folder called providers where it will download the different providers which we defined in the setting. So it downloaded a provider called HashiCorp AWS with the version 4.67.0. Okay, this is a version which we have defined here, 4.67.0. Okay, we have defined this as 4.16 with a tilde symbol, tilde arrow mark. What this means is, like, if keep the major version always, and we can use the last version, like the 16, this minor version, to the latest version you have. Okay, there is a flexibility in like whatever the version you have for the minor version, you can download the latest version and use it. If I give it like equal to, which means it will have the exact version. Whereas if I give the tilde and this arrow mark, it will download the major version called 4 point and whatever the latest minor version available. Okay, so that's why we have the 67. And this patch version could also be the latest version. So this is called semantic versioning, where this is a major version, this is a minor version, and this is a patch version. Okay, cool. Now what I'm going to do is I'm going to delete this one. But before this, I just want to show one more command and then we'll delete this. So we saw plan and apply, which are good. So it will create a plan and the apply will go and do the actual creation in the infrastructure. And there is a command called destroy. This destroy command will destroy the resources which we manage. So meaning, if I go here and if I type Terraform destroy, there are 2 resources we are managing. One is security group, the other one is a EC2 instance. And you have to note down this point, we are not managing VPC or subnets. Okay, we are just getting that information from AWS. Okay, so that's why we use the data construct in Terraform. So I'll say Terraform destroy. So it will check the state and then it will give the information like it's going to destroy my first instance. Okay, and then it's going to destroy security group from TF. Okay, and these are the 2 resources it's going to destroy. Okay, so 0 to add, 0 to change, 2 to destroy. Cool. Now I'll say the value is yes after the confirmation. So it started destroying the EC2 instance first. Also, Terraform creates something called as dependency graph. So, for example, in our case, the EC2 instance depends on security group. Okay. So first it will delete the EC2 instance and then it will delete the security group. So similarly, while creating the resource also, first it will create the security group because EC2 instance depends on the security group. Okay. So it will form a dependency graph and it will do the operations based on that dependency graph. Cool. So let it destroy. Yeah. So it could able to destroy the instance first and then it will destroy the security group also. If I go to my console and if I refresh, you can see my instance is also in the terminated state. This is great. So now we'll come to this Terraform folder. Okay. So what I'll do is I'll just delete this folder rf and then Terraform. Okay. If I do ls-j, there are a few other things. Maybe I'll delete this also. .terraform.log.html. And then let the Terraform state be there. No harm in. Okay, maybe I'll remove this also. Terraform.tf state and Terraform.tf state are backup. Okay. So this is clean. Now we just have our main.tf. Okay. So this is the initial state which you will be in. Now the first command which you have to run is called Terraform init. But before that, make sure you point to the right AWS buckets. So I'll use my profile. I'll say AWS S3LS to make sure I'm pointing to the right AWS account. Okay. After that, I'll say Terraform init. If I do this, it will go to the settings section, which we have. We can see something like finding HashiCorp version matching this tilde 4.16 tilde. And then it found 4.67. So it will download this version and then it will create a folder called Terraform in my local. And then it will create a log file also, which will log my local to the corresponding versions it downloaded. Okay. So this is the first step which you should do. And then you can start doing the other steps, which are plan, apply, and destroy. Okay, cool. I think this looks good. Okay, so we came to the end of the session. Hope you like this session and the hands-on approach which I took. If you have any questions, feedback, or if you like the way I teach, please let me know in the comments. It is very encouraging for me to create videos. And yeah, I'll see you in the next session. Happy learning. Bye-bye.